awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Okay, hai. Assalamualaikum. So, untuk video kali ini, kita akan mulakan discussion set soalan yang pertama untuk sesi 2021-2022. Semoga dengan perbincangan set soalan ini, anda boleh mula study dan prepare for your final exam semester 2. Okay, so jadi apa tunggu lagi? Jom kita mulakan dengan soalan yang pertama. Alright, the first question will cover chapter 1 and it carries 10 marks. Alright, for question number 1. So let's read the question first. So 2 points charges Q1 equal to positive 2 microcoulomb and Q2 is equal to negative 3 microcoulomb are at position 0, negative 3. So dekat sini dia bagi kita koordinat. Alright, and for 0 cm respectively, the position of point P is 0, 3 cm. And the question asks us to calculate what is the magnitude and direction of the electric field at point P. Electric field ya, bukan electric force. Okay, so jom kita mulakan. First kali bila kita dapat soalan, apa yang paling penting adalah kita sketch dululah kita punya koordinat tadi. Okay, so kita ambil ruler sekejap. Okay, so we start with the y-axis first. So let's sketch the coordinate first. Okay, so this is the y-axis. And then we're going to have x-axis. Okay, so let's try to adjust. Okay, so let's say this is the x-axis. Okay, and then so Q1 is located at position of 0, negative 3. So we're going to have Q1, 0, negative 3. So let's say here is negative 3. Okay, so kita letak dululah dekat sini. Okay, so negative 3 here. So this is 0. And then this is positive charge. So I will label as positive. And this is Q1. And then the second, Q2 is located at 4, 0. Alright, 4, 0. Let's say this is the position of second charge, Q2. And Q2 is negative charge of negative 3 microcoulomb. So this is Q2. And then given that point P is at 0, 3 centimeter. So I will put this one. Okay, 0, 3. Okay, it should be around here. Okay, so let's say this is point P and it is at 0, 3 coordinate. Alright, so now let's look at the question. We want to calculate the electric field at point P. Okay, so we want to calculate electric field at point P due to the first charge, which is Q1, positive charge. So positive charge. Okay, kalau Q1 ni positif, means that electric field due to Q1, dia akan keluar macam ni lah. Kita tahu electric field untuk positive charge must be outward from the charge, keluar. Okay, jadi kalau kita sketch, okay, kalau saya ambil ini, kalau kita sketch dia keluar macam inilah. Tak nampak pula. Kita ambil yang lain. Kita cuba ambil color merah lah. Okay, dia akan sketch keluar macam ni lah. Saya buat kecil saja. So, saya tahu direction dia adalah outward. Okay, outward from the charge means that, okay, at point P, the direction of the electric field, okay, this one, E1, I will label as E1. That's mean electric field due to the first charge at point P, okay, and the direction of the electric field due to the second charge, okay, charge yang kedua kita ni adalah charge negatif kan. So direction of the electric field dia mesti inward. Dia akan inward macam ini. Okay, dia akan masuk ke dalam direction of electric field sebab dia negatif, dia akan inward lah dalam macam ni. So kalau saya ambil color, saya nak ambil color merah, so dia akan jadi macam inilah. Okay, so dia akan jadi macam ini. Okay, so adalah E2. Okay, so kalau perhatikan electric field E1 straightly upward. So dia tak ada sengit-sengit, tak ada angle. So no need to resolve. Okay, into X and Y component untuk E1. So, dia memang ke atas, dia memang dalam direction Y component. Okay, so E1 ni dia hanya ada E1Y saja yang ada nilai. E1X dia adalah kosong. Okay. Okay, so sekarang E2 pula kat sini. Dia ada angle kan. So, angle ini kita kena kira lah. So, E2 ni dia sengit sikit. Bila ada angle, kita perlu resolve kepada E2X dan juga E2Y. Sekejap lagi kita akan resolve. Sebelum tu saya nak kira dulu angle dekat sini lah. Berapa angle dekat sini. So kita ambil colour biru. Okay, so this is the angle. Okay, theta. Alright, so how to determine the angle? So let's draw, okay, the triangle. Alright, so this is the angle that we want to draw here. Okay, so we want to calculate that angle. So, dekat sini berapa? 0 to Q2, kita tahu koordinat dia tadi adalah 4, 0. So, means that this is 4. Alright, so this is 4 centimeter. Okay, and this is 3. Sorry. Okay, so this one should be 3. Okay, so 3, 4, and this should be 5. Alright, so the angle, okay, we can calculate the angle. Kita boleh gunalah tangent. Okay, tangent theta is equal to 4 over 3. Boleh juga tangent theta is equal to 4 over 3. So, kita akan dapatlah nilai angle dia. Berapa tu? Angle dia akan dapat, saya dapat kat sini 53.13 degree. Alright, so that one is the value of the angle. Saya dah cari, dah siap-siap dekat sini. So, let's highlight the angle. Okay, and then let's try to answer question number 1. Okay, so we want to calculate electric field at point P. So, in order to calculate the magnitude, sebab saya dah kata tadi, E2 dia ada angle kan? Sebab dia ada, dia sengit sikit macam ni. So, kita kena resolve kepada E2X dan E2Y. Okay, that's mean in order to calculate EP, kita kena guna formula inilah. Sebab kita ada X and Y component. So, total electric field in X component, okay, at point P squared plus total electric field, okay, Y component at point P squared. Okay, so kita akan gunalah formula ini untuk kita selesaikan soalan yang pertama. Alright, so now before we start, okay, kita dah tahu EP1. Okay, kita tengok kat sini EP1. Okay, dia hanya ada Y component only. Alright, tapi untuk E2, so since we have angle, sorry, so we will use this one. Okay, so for E2, since we have angle, so kita kena resolve kepada, so the angle is here. Okay, so kita akan resolve kepada E2X, which is E2 sin theta, and kita ada E2Y, which is equal to negative E2 because the direction is downward, cos theta. Okay, so kat sini dia ada X and Y component. Okay, so itu you kena faham dulu. Okay, mana yang you kena resolve. Kalau ada yang kata dia nak buat bentuk table terpulang, boleh juga buat bentuk table. Okay, tapi saya selesa buat macam inilah. Okay, so sekarang kita nak kira EP1 dulu. Kita kira dulu nilai EP1 dan juga E2. E1 lah, saya letak kat sini E1. E1 dan juga E2. Okay, so kalau saya kira untuk E1, okay, formula dia adalah K-Q1 over, okay, over R1 squared. R1 squared adalah jarak antara point P dari point P ke charge Q1. Okay, E1 jarak antara R1 ini adalah jarak antara point P, okay, daripada charge Q1. So, berapa jarak dia tu? Bukan 3 cm, tetapi 3 tambah lagi 3. So, it is 6 cm. Okay, so this is 6 cm. Alright, so it should be equal to K, masukkan nilai dia. Okay, charge Q1 is positive 2 micro, so negative 6. Okay, and the distance is 6 cm. Make sure you change to meter squared. Boleh? Okay, So it is equal to 5 times 10 power of 6, okay, Newton per Coulomb. Alright, and then I will straightly calculate E2. Okay, so E2 KQ2 over R2 squared. So R2 is the distance from point P to charge 2. So this is the hypotenuse of this triangle. So kita dah tahu tadi 5 cm, is it? So it's from here, sini sampai sini. Sekejap saya betulkan. Okay, daripada sini sampai sini 5 cm. Okay, so it's equal to 9 exponent 9, and charge Q2 is negative 3 microcoulomb. Ingat ya, untuk electrostatic force and field dalam calculation jangan masukkan negative sign. Kenapa? Sebab kita dah consider direction of the electric field. Tadi sebelum mula-mula tadi sini kita dah lukis dia punya direction. Okay, so this is 5 cm. Okay, so it should be equal to 1.08 exponent 7. Okay, cuba kira ya. Tekan calculator. Practice tekan calculator. Alright. So, I will highlight here. Okay, here, please don't include negative sign. Okay. Don't include negative sign. Alright. So, now, let's move. Okay, we want to calculate total. Okay, total electric field at point P, okay, in X component. Okay, kita akan tulis macam ni lah. Total electric field in X component at point P. So, siapa sahaja yang ada in X component? Siapa je yang ada X component? Hanya ini. Hanya E2X sahaja. E2X sahaja yang ada X component. So, kalau kita nak tulis, kalau nak tulis juga boleh, E1X plus E2X. E1X, okay, E1 tak ada in X component, so kosong. So, dia akan jadi 0 plus E2X, look at here, E2X, we have E2 sin theta, okay, and the direction of E2X is to the right. Okay, means that it is positive value. So, dia akan jadi E2 sin theta, it is 53.13 degree. Okay. So, nilai E2 tadi, saya masukkan theta dulu kat sini lah, angle dulu. Okay. And then, let's calculate. E2 kita dah kira tadi, 1.08 exponent 7 sin 53.13 degree. Okay, masukkanlah nilai dia tadi. Okay, and then, total electric field in X component at point P should be equal to positive, okay, 8.64 times 10 power of 6 Newton per Coulomb. Okay, and this direction, since this is positive, so means that it is to the right. Okay, and then for the second part, okay, it should be total electric field in Y component at point P. So, kedua-duanya ada. E1, tengok dekat sini, E1 direction dia upward, E1Y is upward, but E2Y is downward direction. Okay, so dia akan jadi E1Y positive. Okay, dia akan tambah dengan E2Y. Okay, E2Y tadi nampak tak kita dah letak negatif dekat sini. Yang warna purple ini saya highlight dengan warna kuning. So, kita substitute nilai dia. So, E1Y, so tak ada angle. So, kita boleh masuk terus nilai dia. 5 times 10 power of 6 plus E2Y adalah negatif E2. Negatif E2 cos 53.13. So, E2 tadi kita dah kira kan? So, kita just substitute all the values. So, E2 1.08 exponent 7 cos 53.13 and EYP, that's mean total electric field in Y component at point P, okay, it should be equal to 1.48 exponent 6 Newton per Coulomb, okay, and sorry, it should be negative, okay, negative 1.4, okay, so negative sign showing that the direction of total EYP is downward direction. Okay, downward direction. Sorry. downward. Okay. Alright. So now finally we can calculate therefore, okay, total electric field. Okay, we can calculate the magnitude of the electric field at point P. Okay, square root total electric field X component at P squared plus total electric field Y component at P squared. Okay, so we can substitute all the values yang kita dah kira dekat atas tadi. So finally kita akan dapat jawapannya adalah okay, 8.77. Okay, you masukkanlah, you gantikan nilai dia betul-betul. Make sure you cuba kira ya. 10 power of 6 Newton per Coulomb. So, bila jawab soalan, jangan terlupa untuk letak unit yang betul. Jika jawapan akhir unit awak tidak letak, so akan hilang satu markah iaitu jawapan akhir walaupun jawapan awak itu betul. Okay. And then, soalan minta sekali direction. Okay, jangan lupa direction. Okay, so we want to calculate the direction. So, angle theta. Okay, let's try. So, I will put here. Okay, theta is equal to, this one's for direction, okay? Theta is equal to inverse tangent total electric field in Y component over total electric field in X component. Okay, so we can substitute all the values. So negative for Y component, negative 1.48 exponent 6 over 8.64 exponent 6. Alright. Therefore, the angle theta, okay, you akan dapat negative 9.72 degree. Ataupun kita kata, theta dia adalah 9.72 degree and it is below positive x-axis. You dah belajar semester 1 dulu. Okay, tapi masih dia tanya, madam, bagaimana untuk kita tentukan? Okay, macam mana untuk kita tentukan positive, above positive x-axis or below ataupun below negative x-axis. Okay, so now look at here, the values of total YP is negative, alright, and this is positive. So since total YP is negative, alright, so means that the direction of total Y, okay, P, total, so letak sini, total EYP should be downward. Okay, and X is positive, so to the right. Okay, so total EXP to the right. And this is the resultant electric field at point P. Kita dah kira tadi. And where is the angle? So the angle is here. Yang kita kira. So the angle here is 9.72 degree. Alright, so this is negative x-axis and this is positive x-axis. So daripada sini kita nampak dia adalah below. Okay, below positive x-axis. Okay, bawah bawah positive x-axis. Alright, so finish question the first part, which is part 1. Alright, and then for the second part, we want to calculate the electric force experienced by a test charge Q. Okay, let's say we have a test charge Q equal to 4 microcoulomb, and we locate this charge at point P here. Kita letak dekat sini. Okay. So, dia akan jadi macam mana? Okay, question number 2. So, electric force experience. So, kita boleh guna sajalah formula F is equal to QE. Okay, so based on this equation, we can straightly calculate the magnitude. Okay, hanya magnitude saja kita boleh kira dulu. Okay, so F is equal to Q4 exponent negative 6. E dekat point P tadi, berapa? Kita dah kira 8.77. Okay, and then finally, we can calculate, okay, 4, so jom kita kira 4 exponent 6, alright, sorry, 4 exponent negative 6 times 8.77 exponent 3, right? Sorry, 8.77 exponent 6, okay, exponent 6, so you akan dapat 35.08 Newton, okay, so 35.08 Newton is the magnitude. Okay, so this is the magnitude. Okay, now, so what is the direction? Okay, direction of the force. Okay, so the direction of the force is same direction as the resultant electric field at point P. Okay? Okay? So, since the direction of EP is 9.72 below positive x-axis, okay, yang ni tadi yang kita dah buat tadi kan? Okay, dekat sini. Okay, this is direction of EP. So, the same direction lah. Means that the electrostatic force, okay, electrostatic force F, okay, kat sini. Kalau kita kira, sama. Direction dia akan jadi sama dengan electric field at point P. Okay, which is below positive x-axis. And the angle here, okay, should be equal to 9.72 degree. Okay, sebab apa? Kenapa sama dia punya direction? Okay, because this is the scalar quantity and we times with the, this one is the vector quantity electric field, direction of the electric field tadi kita dah kira. So, force dia akan samalah direction dia. Okay, direction of the resultant force experienced by a test charge of 4 microcoulomb at point P should be same direction as the electric field at point P. Alright, so now we finish discuss question number 1. So we will proceed to the second question. Alright, question number 2. So let's try to discuss. Okay, so here we have a figure of 3 capacitors, C1, C2, and C3. So they are connected in series and parallel. So if you look at this circuit, okay, as we know that C2 and C3 are in parallel, and C1 and this group are in series. Okay, so determine the electric energy stored in the capacitors. Okay, so we want to calculate the electric energy stored in the capacitors. Means that we're going to use this equation U equal to half C total V squared. So in order to answer this question, I will find first what is C total. Okay, so kalau kita nampak dekat sini, current pass through this circuit, and then kita ada junction dekat sini. Okay, so saya pernah discuss sebelum ni, once you ada junction, so you nampak, oh, this group and this group are parallel. Kenapa? Because the current here is split into 2 paths. Alright, so yang color hijau ni dia akan split kepada color merah dan juga color apa? Kita letak satu lagi color lah. Color biru. Okay, so sini. So means that C2 and C3 are in parallel, and then here they will combine again. Alright, and this is C1. Okay, so means that this group, okay, C23 and C1 are in series. Okay, so before we calculate the energy stored, so we need to calculate first what is the total capacitance in this circuit. Okay, so I will write that C23, I will start with C2 and C3 first, so they are in parallel. Okay, so question number 2 daripada chapter 2, okay, and hanya membawa 3 markah, okay, lebih kurang lah 3-4 markah macam tu lah. Okay, so equation to calculate C23, so for parallel, okay, so capacitor jangan terbalik ya dengan equation resistor. So C2 plus C3, so C2 is 2 micro and C3 is 5 micro. So 2 micro plus 3 micro. So C23 is equal to 5 microfarad. Okay, and then after we combine C23, okay, C2 dengan C3 kita combine jadi C23. So the circuit would become like this. Okay, so kalau kita lukis dia akan jadi macam inilah. So we have C1, C23, and this is the voltage. Okay, so 12 volt, and this is C1, and this is C23 yang kita dah kira tadi, 5 microfarad, this one. Okay, and then look at this group. Okay, so if current flow in this direction, kita nampak tak ada junction. That means C1 dan juga C23 mereka adalah series. So if we want to calculate the total capacitance, so let's try. So C1 and C23, they are in series. Okay, so this time we can combine all the all the capacitors here. C1 dengan C23, they are in series. So we can use equation of series lah untuk capacitor. So kita tahu 1 over C total is equal to 1 over C1 plus 1 over C23. Okay, so kita boleh kira lah C total. Okay, boleh straightly tulis macam inilah 1 over. Okay, 1 over C1 is 1 over 4. C1 is 4 microfarad plus 1 over 23. C23. C23 is 5 micro. So 1 over 5. So finally C total you akan dapat 2.22. Okay, saya dapat 2.22 microfarad. Therefore, we can finally find U, electric energy stored, is half C total V squared, sebab kita dah ada nilai V tadi kan. So kita boleh kira terus 1 over 2, C total 2.22 micro. So V kita adalah 12. Okay. So kita akan dapatlah nilai dia. Berapa? 1.6. 1.6 times 10 power of negative 4 joule. Okay. So this is the answer for question number 2. So let's proceed to question number 3. Alright, question number 3A. So soalan ini ada 6 markah. Okay, so let's read the question. Figure 2 shows the arrangement of 4 resistors in a circuit. So we have R2, R1, R3 and R4. Okay, so all the values of the resistance is given. Okay, so calculate the potential difference across R1. Okay, so bila soalan tanya potential difference across R1, means that we want to find V1, okay, voltage across V1. Okay, and then before we start, I want to simplify this circuit. Sebenarnya circuit ini dia simple sahaja. Okay, maksud saya dia adalah macam inilah. So this is the positive terminal. Okay. And then we have the first resistor. Sorry. This is the wire and this is the first resistor R1. And this is R2 and this is R3. And we're going to have another R4. Okay. So this is R3 and this is R2. Alright. So positive terminal means that the current will flow from here. So ada junction kan? So bila ada junction maknanya current will split into R1, the green color, and we're going to have the purple color in this direction, R23. Maknanya sekarang apa dia? R1 dan juga R23 are in parallel. So the fact is R1 and R23 they are in parallel. Okay, so bila mereka parallel, maksudnya apa? So since R1 and R23 are parallel, so voltage, alright, voltage kalau kita kira V23, okay, kita akan dapatlah V1, voltage across V1 ni sebenarnya sama dengan voltage across 23. Dan jangan lupa dalam soalan dia dah bagi satu hint di mana current that pass through R1 and R3, okay, current yang berwarna purple ini tadi, okay, kita namakan current itu adalah I23 and it is equal to 4 ampere. Okay, so bila kita dah ada I23, kita boleh carilah V23 sebab sekarang soalan nombor 1 objektifnya kita nak cari V1. This potential difference across R1 means that voltage across R1, V1. So kita dapat satu maklumat mereka adalah parallel. So V1 is equal to V23. V1, okay, parallel voltage mesti sama. V1 equal to V23. Nilai voltage across R1 sama dengan nilai voltage across R23. Okay, so nak tak nak kita kena combinekan dulu R23. Okay, so R23, okay, they are in series, right? This one, R2 dan juga R3. So we need to calculate first R23. So they are in series. Okay, therefore in order to calculate R23, so R2 tambah dengan R3. Okay, So R2 nilainya adalah 2 ohm, R3 is 1 ohm. So 2 plus 1. So R23 is equal to 3 ohm. Okay, so based on this information, finally, therefore, we can calculate V23. Okay, V23, I kita dah ada kan, I23. V23 is equal to I23 times R23. Okay, so I23 kita tadi berapa? 4. So R23 kita adalah 3, right? Okay, 4 and R23 kita adalah 3. Betul ke? Okay, 2 tambah 1, 3. Okay, so V23 is equal to 12 volt. So, soalan tanya V1 voltage across R1. So, therefore, V1 is also equal to 12 volt. Okay, so this is the answer. Okay, so finish the first part and then the second part. Okay, so determine the reading shown by the ammeter in the circuit. So for question number 2, okay, actually we want to calculate what is the current that passed through R4. Okay, I4. Okay, so if you look at this example, okay, you can see here that we have I4. So saya akan lukis dekat sini adalah I4 yang kali hijau ini. Okay, so in order to calculate I4, since we already know that the current that passed through R23 is I23 4 ampere, okay, dan R1 ni kita boleh cari. Kita boleh cari ini current yang lalu dekat I1. Sorry, current yang lalu dekat R1. Sebab apa? Sebab current yang lalu dekat R4 ini sebenarnya adalah combination. Okay, dia kan ada junction dekat sini kan? Dia adalah sebenarnya combination daripada current daripada I1 dan current yang daripada I23. So, dia akan jadi I1 plus I23. Okay, so I23 tak ada masalah, soalan dah bagi. So, now we need to find what is the value of I1. Okay, so where I1 is equal to V1 over R1. Voltage across R1 kita dah kira tadi 12 and R1 is equal to 5, means that current I1 that pass through R1, okay, resistor 1 tadi, is equal to 2.4 ampere. Okay, so bila kita dah dapat nilai I1, therefore finally we can calculate I4. Okay, I4 is equal to I1 2.4 plus I23 is 4 ampere, and the answer is equal to 6.4 ampere. That's mean the current, okay, the current that pass through R4, okay, dan dekat sini kita connectkan dengan ammeter. So ammeter ni akan baca current I4. Okay, means that the ammeter will show you the reading of current I4 and it is equal to 6.4 ampere. Okay, so finish question 3A. So ada 6 markah dekat sini And then look at the second part. Okay, for question 3B. So here we have Kirchhoff law, okay, or Kirchhoff rule. So the internal resistance of all the batteries are negligible. Calculate the current I1. So this is labeled as I1, I2, sorry, this is I2 and this is I3. Okay, let's say we choose this as the junction. Okay, kita ada junction X and junction Y. Okay, so now bila saya dapat soalan Kirchhoff, the first step saya akan lukis dulu arrow yang kecil ni. Kita tahu current must flow from positive terminal to negative terminal, right? So current come out from positive terminal. Saya akan lukis dulu arrow yang kecil yang warna merah tadi. Okay, so for the second step, saya akan lukis the direction of the loop. Okay, untuk first loop and second loop. Okay, so sekarang kita tengok dulu loop kita nak clockwise ataupun anti-clockwise. So kita tengok dulu 7 volt and 6 volt. Dekat loop yang di atas ini, kita namakan loop yang pertama, ada 2 EMF. Alright, so tengok EMF mana yang lagi besar. So saya nampak, yes, EMF yang inilah 7 volt. So saya akan follow direction of this small So saya akan follow the direction of this small arrow in order to determine the direction of the loop. Okay. So ini saya akan macam ni lah ke bawah. Okay. So dia akan jadi macam ini. Okay. That one is anti-clockwise. And for the second loop, same goes to the second loop, 6 volt and 5 volt. So I will use this arrow as my guidance in order to determine the direction of my second loop. So dia start ke kiri kan, sorry, ke kanan kan. So dia akan jadi macam inilah. 1, 2, 3, 4. Okay, that one is clockwise direction. This is anti-clockwise, follow 7 volt direction of this small arrow, and this is following the direction of this small arrow. Okay, based on 6 volt lah. 6 volt dengan 5, 6 volt lagi besar. Okay, so now let's write the equation. 3 equation kita nak tulis mesti betul lah. Okay, so kita choose at junction. Okay, at junction Y. Okay, we use total current in is equal to total current out. That's mean total current direction yang into the junction hanya ada apa? Ini saja I1. I1 arah dia ke dalam junction, masuk ke dalam junction. That's mean bahagian ini total current in is I1. Okay? Is equal to, okay, current yang out from the junction adalah I2 dan juga I3. Okay? So saya susun balik equation ini. I1 equal to, sorry, I1 minus I2 minus I3 is equal to 0. And this is equation number 1. Okay, saya dah settle equation number 1. Pastikan betul lah. Okay, dan kita move on kepada second part, iaitu equation number 2 daripada loop yang pertama. Okay, we start with the first loop. Okay, so we start with the first loop and we're going to use second rule, total EMF is equal to total IR. Okay, so sekarang you tengok dekat loop yang pertama, you ada berapa EMF? You ada 2. Okay, compare the direction of your loop with the small arrow, okay, the red one, the red color of arrow yang you lukis dengan you punya loop. Which one is the same direction means that the value of the EMF should be positive. Okay, itulah tips dia supaya you tak salah lah. So 7 volt is positive, same direction. This is also positive because same direction. So dia akan jadi 7 plus 6 is equal to, and then look at how many resistors in this circuit. Okay, the first loop. So we have the first resistor. Okay, let's say this is the first resistor. Okay, 3 ohm. Alright, so 3 ohm, current apa yang lalu dekat dia? So kita nampak dekat sini current yang lalu dekat dia adalah I1 lah. Sebab I1 datang daripada sini, I1. Okay, so dia akan jadi 3 I1. Okay. Okay, and then look at the direction of current. I1, same direction tak dengan loop yang kita lukis? Yes, same direction. Means that the value of I1 here is positive. Positive 3 I1. Okay, and then the second current, sorry, the second resistor. Okay, kita ada current I3 that pass through 4 ohm resistor. Okay, kita ada I3 here that pass through the 4 ohm resistor. Okay, so same direction tak? Yang kali hijau ini current I3. Yes, same direction. So still positive. But this time we have resistance of 4 ohm times the current I3. Sebab current I3 yang lalu dekat dia. Okay, so we try to rearrange that equation. So I'm going to have 3I1 plus 4I3 equal to 13. So this is my second equation. Okay, and then my third equation must come out. And then my third equation, okay, must be from the second loop. Okay, loop yang kedua. Alright, so look at the second loop, sama juga. Tengok pada current. Tengok pada voltage. Okay, voltage ini 6 volt, same direction tak dengan loop? Yes, same direction. This one, same direction tak? Yes, same direction. Means that they are all positive value. So total EMF should be 6 plus 5 equal to, 6 plus 5 equal to, current that pass through 2 ohm is I2. Okay, I2. Okay, so dia akan jadi same direction tak? I2. Yes, same direction with the loop I2. So positive 2I2. Okay, and how about this one? Okay, the direction of this one, the direction of current that pass through 1 ohm resistance, sama juga. Color yang color kuning, I2. Sama juga. So, same direction, right? So, I2 here. Okay, so dia akan jadi plus 1 I2. Still I2. And then the last one, okay, dekat dalam loop yang kedua, kita ada 3 ohm resistor. Okay, 3 ohm resistor, current yang color biru yang lalu dekat dia, iaitu I1. Same direction with the loop yang kita lukis tak? Yes, same direction. So, it should be 3I3 or I1. I1 lah. Sebab this is I1. So, I1 mesti all the way here. Okay, dia punya perjalanan dia sini. I1, biru. Bila sampai junction, baru dia jadi kuning dan hijau. Okay, so, kita akan ada 3I1. So, it's still positive because same direction, I1. Okay, I1, direction of I1 dengan loop yang kita lukis kat bawah ni, same direction. So, rearrange that. So, now rearrange that equation. So, kita ada 3I2 plus 3I1. Saya susun I1 dululah. Okay, 3I1 plus, that one is 3I2 is equal to 11. So, equation number 3. Okay, so, now we want to find I1, I2 and I3. So, by using your calculation, okay, gunakan. So, now we want to calculate I1, I2 and I3. So, by using your calculator, so kita ada, nanti kita akan dapat masukkan nilai X, Y, Z. Okay, and this is equal to, okay, ini adalah nilai A, B, C, D lah. You masukkan nanti A1 apa dia, mewakili I1, I2, I3. Okay, so we start with the first equation, equation number 1. Okay, I1 ni berapa tu? 1, negative 1, negative 1. 1, negative 1, negative 1. So, 1, negative 1, negative 1, 0. And then, equation number 2. Sama juga, I1 ada tak? Ada, 3. I2 ada tak? Tak ada, kosong. I3 ada? Ada, positive 4. And equal to what? 13. So, 3, 0, 4, 13. Alright, and equation number 3. So, we're going to have I1. We still have I1 here. 3I1. We have positive 3I2. 3. But we don't have value for I3. And it's equal to 11. So, I3 yang kat sini nanti kotak ni kosong lah. So, 3, 0, 11. Okay, you tekan you punya calculator. Therefore, finally, jawapan you akan dapat nilai. Dia akan bagi jawapan X, Y, Z. Okay, so X awak mewakili I1. Nilainya adalah 2.52 ampere. Okay, and I2 is 1.15 ampere. And I3 is equal to 1.36 ampere. Okay, so this is all the answers for question number 3B. Alright, so finish question number 3. Let's proceed to question number 4. Alright, question number 4. So let's start with question number 4A first. So here we have a solenoid has self-inductance of 45 microhenry. So if the current in the solenoid decreases uniformly from 5.5 ampere to 0 ampere, and the time taken to decrease to 0 ampere is 2.5 microseconds. Okay, so determine the magnitude of the self-induced EMF through the solenoid. So we want to find the induced EMF. So remember, induced EMF is equal to negative L di over dt. Okay, so we will use this equation. And remember, okay, the self-inductance, this is L, 45 microhenry. Okay, so initial I is given 5.5 ampere and the final I is 0 ampere and the time taken for delta T is 2.5 microsecond. Alright, make sure you keluarkan semua maklumat dia. Okay, and then in order to calculate the induced EMF, so 3 markah, so negative, so L is 45 micro should be negative 6. Alright, and the I dt is I final minus I initial. So 0 minus 5.5, over the time taken to decrease to 0 is 2.5 micro, so -6. Okay, so substitute all the values and then the final answer should be 99 volt. Okay, so finish for A and question for B. Okay, so let's read the question. So we have 7 marks here. Alright, so for question B, okay, question B, so here we have a long solenoid. So this is the solenoid and the wire loop. So this is the wire loop. Are placed as shown in figure 1. Alright, the solenoid has 600 turns. So N, this is the end of the solenoid, where it is equal to 600 turns. With the length of the solenoid is given, okay, 1.5 meter, and the cross-sectional area is in 4.2 centimeter squared. So this one is centimeter squared. Make sure you change to meter squared. Jangan careless bila you tukar kepada meter squared. Okay, kita dah buat banyak kali dah. Okay, semester 1 you dah belajar bagaimana you nak tukar unit kepada centimeter squared kepada meter squared. Bukan tukar unit daripada centimeter ke meter, tetapi centimeter squared ke meter squared. Okay, saya pasti awak dah tahu dah ni. Okay, so the current that flows in the solenoid is increasing at rate of, so ada perkataan rate of, so look at the unit, 120 ampere per second. So ini bukan the change of current, okay, dia ada rate of change of current. Okay, dia meningkat pada kadar, so that's mean this is di over dt. So di over dt is given 120 ampere per second. Okay, so that one is di over dt. Okay, so for question number 1, okay, so saya rasa saya nak pindah ini maklumat ke tepi sikit. Kita kecilkan sikit boleh tak? Okay, and then we bring this side. Okay, so for question number 1, so let's start. Okay, calculate the magnitude of induced EMF in the wire loop. Okay, wire loop outside the solenoid. Wire loop dia refer kepada ini yang saya warnakan dengan warna hijau ini. Ini wire loop. So kita nak kira the induced EMF. Alright. So the induced EMF for the wire loop, okay, it should be equal to negative. So the number N here should be the number of the loop for the coil. Okay. And since there is an increasing in current, okay, ada peningkatan current pada kadar ini, maknanya ada perubahan magnetic flux dphi over dt. Okay, so kalau saya tulis dekat sini, okay, dphi over dt. Okay, so dphi over dt, and as we know that equation for the magnetic flux, okay, is equal to BA cos theta. Okay, alright. So ini kita consider as cos 0, 1. Okay, so we take it the magnetic flux, okay, equal to BA. Cumanya B adalah magnetic field. Okay, magnetic field. Okay, magnetic field formula apa kita nak pakai ni? Magnetic field. Okay, jadi magnetic field ni datangnya daripada mana? Datangnya daripada ini. Okay, magnetic field is come from the solenoid. Okay, maknanya wire loop, so tengah-tengah ini ada magnetic field. Okay, magnetic field ini dia boleh berubah disebabkan ini, di over dt, kadar peningkatan current. Okay, bila ada perubahan current, okay, sama ada current itu increase ataupun decrease. In this case, current itu increase. So when the current is increasing, maknanya B ini dia akan increase juga. Okay, so bila ada perubahan B daripada original B, and then ada pula increasing in current, okay, so ada perubahan magnetic field. So bila ada perubahan magnetic field, akan ada perubahan magnetic flux. Ini dia dphi over dt. That's why we need to calculate what is the induced EMF dalam coil tersebut menggunakan equation ini, disebabkan ada perubahan magnetic flux ini tadi. Kenapa ada perubahan magnetic flux? Patah balik sebab ada perubahan atau peningkatan di dt ini. Okey, jadi B ini, magnetic field ini, dia mesti rujuk kepada siapa? Okey, dia mesti rujuk kepada magnetic field at center of the solenoid. Magnetic field ini kita kena kira menggunakan equation. Okay, magnetic field, saya tulis dekat sini Okay, magnetic field at center of solenoid. Okay, and remember from chapter 4, So magnetic field at center of the solenoid, kita akan kira mu naught. Okay, mu naught apa? Mu naught Ni. Mu naught Ni. Okay, where this is, and here is the number of turns per length. Okay, number of turns per length. Okay, you boleh check balik nota awak, N equal to N over L. Okay, jadi bila kita masukkan dalam equation ini, okay, kalau saya masukkan, dia akan jadi the number of turns untuk coil tadi 1. Okay, ini you boleh potong lah 1. So negative. So kita akan dapat d dt BA cos theta kan. So BA lah. So kita ada perubahan apa? Kita ada perubahan B. Okay, dB over dt. Boleh? Okay, so B tadi kita gantikan, formulanya adalah negatif A. Okay, d dt. B tadi kita gantikan mu naught. Mu naught N kecil darab dengan I. So nampak tak dekat sini kita ada di over dt. So di over dt. So kita gantikan. Saya bawa okay, semua N kecil adalah okay, number of turns per length, N over L of the solenoid. L ni adalah length of the solenoid. So kita ada di over dt. Okay, jadi bila kita masukkan dalam kita punya equation ini, kita boleh dapatlah A berapa? Okay, A dia tadi 4.2. Okay, kita dah kira kan, mesti dalam meter squared. Negative 4. And then mu naught is 4 pi times 10 power of negative 7 N over L, the number of turns for the solenoid. So this is referring to the number of turns for the solenoid and length of the solenoid. So 600 over 1.5. Okay, and then last kali di over dt. So di over dt is 120. And finally, the induced EMF, you akan dapat negative 2.53 times 10 power of negative 5V. Okay, since the current is increasing, the I over dt is increasing, that means the magnetic field also increasing. So the induced EMF would be opposite direction as the direction of the original current tadi. Okay, and then kita boleh tulis lah. Saya boleh tulis kat sini, therefore, the magnitude, okay, if we look at here, the magnitude of the induced EMF, okay, is equal to 2.53 times 10 power of negative 5 volt. Okay, kita buat ayat sikit lah kat bawah ni. Okay, kita bagi tahu magnitude dia berapa. Boleh? Okay, jadi untuk jawab soalan number 1 ini, ada dua cara. You boleh buat cara ini, ataupun you boleh buat menggunakan mutual inductance punya equation. Kenapa mutual inductance? Sebab kita ada dua perkara dekat sini. Satu solenoid, satu lagi wire loop. Solenoid dan juga wire loop. So melibatkan dua benda macam tu. Okay? So number 1, okay? So number 1, okay? So kita boleh juga, or saya tulis kat sini you boleh guna formula mutual inductance. Mutual inductance antara siapa? Antara magnetic field daripada solenoid dengan coil of the loop tadi, ataupun the wire loop tadi. Okay, so you can use equation, okay, mu naught, okay, sebab kita nak kira induced EMF, right? So look at here, so the induced EMF, okay, is equal to negative M di over dt. Yang ni lebih simple lah. Okay, kalau you guna equation ini boleh. Okay, tetapi mesti cari dulu what is the mutual inductance M. Okay, where M, okay, is equal to mu naught times the number of turns for this coil times the number of turns for the solenoid times the area, okay, of the solenoid lah. Area of the cross-sectional area of the solenoid. Alright, ya betul. Okay. Okay, and then L pun sama. Kita masukkan guna formula. You kira lah dulu ada mutual inductance. Okay, so mu naught is 4 pi times 10 power of negative 7. And C, the number of coil is 1. Number of turns for the solenoid is 600. And area is 4.2 times 10 power of negative 4. over the length should be 1.5 meter. Okay? Alright. So now, the mutual inductance, you kira saya akan dapat 2.11 times 10 power of negative 6 Henry. Okay. And then, the induced Cmf is equal to negative m di over dt. Okay. So, the mutual inductance kita dah kira tadi. Okay, 2.11 exponent negative 7 di over dt. Soalan dah bagi. Kita masukkan saja. So, you akan dapat jawapannya sama dengan cara yang pertama yang kita buat tadi. So, this is the answer. Alright. So, finish for 4B1. And then 4B2. So, 4B2 kita nak kira. Mudah je kan yang tu. The magnitude and direction of the induced current within the wire if its resistance is 2.5. Okay. Okay. Saya buat dekat sini number 2. So, we want to determine the magnitude and direction of the induced current. So, given that the resistance of the wire loop is 2.5 ohm. So, that's mean in order to calculate the induced current, we're going to have induced EMF over R. Okay. So, kita dah dapat tadi kan. So, kalau kita masukkan saja nilai dia, kita dapat kira dulu dia punya magnitude. Okay. So, the magnitude of the induced current 1.01 exponent negative 5 ampere. Unit jangan lupa ya bila you buat soalan. Okay, nanti hilang markah tak ada unit. Okay. Itu baru dia punya magnitude. So, dia nak direction. Clockwise or anti-clockwise, the direction of the induced current in the wire loop. So now look at this solenoid. Okay, so here we have the direction B. B here, this is referring to the original magnetic field. Okay, the original magnetic field is into the page. Kalau tengok daripada depan solenoid. Kalau you tengok daripada tepi, you akan nampak direction of the magnetic field is to the right. Kita tengok daripada depan lah. So, the into the page. Boleh, mana-mana boleh. So, when the question state that the current that flows in the solenoid is increasing, okay, I is increasing means that automatically the magnetic field here should be increased. Therefore, the induced magnetic field, okay, the induced magnetic field will be opposite direction. Sebab apa? Sebab bila current increase, B original ini akan increase. Okay, but the system of the wire loop, kawasan ini, dia akan cuba untuk oppose any change of the increasing in the magnetic field. So, dia akan create induced magnetic field that is opposite direction with the original magnetic field. Faham So, ini saya ada discuss secara detail dalam video short animations chapter 5. Okay, sebab masih ada lagi yang tak tahu bagaimana you nak tentukan direction of the induced current. Okay, so saya akan tulis dekat sini. Okay, in order to determine the direction, okay, so since the current is increasing, that's mean the original B would be increased. Okay, maknanya bila ada perubahan magnetic field, automatically akan ada perubahan magnetic flux. Sebab itu wujudnya induced EMF. Okay, so when B is increasing, therefore, automatically the induced magnetic field will be in opposite direction. Okay, opposite direction as the original magnetic field. Saya letak macam itu saja. Awak tulis ayat yang betul-betul. Okay, kalau kita lukis, okay, so the original magnetic field should be, into the page, right? Okay, into the page. So B. So since current is increasing, so B would be increased. Therefore, the induced magnetic field akan jadi opposite direction sebab dia nak cuba oppose the change in increasing of B. Okay, opposite direction. Opposite direction dengan kalau tadi original magnetic field into the page, so induced EMF should be out of the page. Saya guna color merah. Okay, so be induced. And then by using your right hand grip rule, okay, your thumb mesti pointing ke arah keluar daripada kertas soalan awak. Keluar daripada kertas soalan awak. And then you akan nampak your other 4 fingers, dia akan curl ke arah apa? Dia akan curl ke arah anti-clockwise direction. Okay, so means that the direction of induced current, okay, therefore direction of induced current Okay, should be in anti-clockwise direction. Okay, so this is the answer for question 4. Alright, so now finish question number 4. So let's proceed to question number 5. Alright, question number 5. So this is about chapter 6, alternating current. So the question states that we have a voltage equation here. 20 sin 100t is applied across 10 ohm resistor where V is in volts and T is in seconds. Okay, so kita hanya ada pure R. Okay, sebab kita ada resistor saja dekat sini. So pure R circuit. Alright, so now we want to calculate determine the current. Determine the current when T is equal to 10 seconds. Okay, so T is equal to 10 seconds. So since we want to calculate the current, so kita tahu V is equal to IR. So I is equal to V over R. Okay, so kita nak cari I kan. So V tu kita masukkan equation yang dia dah bagi dekat atas ni. 20 sin. Okay, 20 sin 100t over R. R kita adalah 10. Alright, 10 ohm. Okay, so 10 ohm. And then kita boleh kira teruslah. Kita masukkan nilai. So T tadi saya terus ganti saja sin 100 times 10. Okay, so untuk part ini pastikan you punya calculator. Okay, you nak selesaikan yang ini. Sin, right? So pastikan you punya calculator in radian mode. Okay, so bila kita kira, pastikan you punya calculator dalam radian mode lah. So you akan dapat I is equal to 16.538 over 10. Okay, so I you akan dapat 1.65 ampere. Kan? So this is the answer lah for A1. Okay, and then for A2, the amount of heat produced by the resistor in 3 minutes. Okay, saya akan buat ke tepi ni lah. Okay, question number 2. So we want to calculate the amount of heat produced by the resistor in 3 minutes. Okay, maknanya bila kita cerita pasal the amount of heat produced, okay, so kita heat dia punya unit apa? Heat kan? Joule kan? Okay, so sebenarnya kita nak kira energy. Energy dissipated in resistor. Okay, kita nak kira energy dissipated in resistor. So formula energy adalah power equal to energy over time. So energy is equal to power darab dengan masa. Okay, so kita nak guna formula yang inilah. Okay, so sekarang kita ada time 3 minutes. Okay, but we don't have P, power dissipated in resistor. Kita dah belajar kan? So power dissipated P. Okay, ini mesti saya tulis dekat sini, must be power dissipated in resistor. Okay, so what is the equation of power dissipated in resistor? Okay, so kita boleh tulislah power dissipated, ataupun kita panggil nama lain dia, kita sebut juga average power. Okay, and it is equal to I RMS squared times R. Ingat lagi tak? Okay, equation ini I RMS S times R. Okay, this one. Okay, jadi sekarang kita boleh kira lah. Kita boleh kira, kita boleh masukkan dalam ini. E is equal to power, kita nak masukkan tadi kan, I RMS squared R times dengan T. Kan nak darab T. Okay, cumanya sekarang untuk I RMS kita tak ada nilai. Kita tak ada nilai I RMS. Okay, tak boleh ya, you ambil I ini 1.65 ni tak boleh. Okay, this is the current at T is equal to 10 second. So I RMS kita boleh kira, okay, menggunakan equation apa? Okay, so tengok dekat sini lah. Okay, bila kita nak kira, kita tahu ini I RMS. Okay, we already know that I RMS is equal to I naught. Okay, that means peak current over square root 2. Okay, peak current pun tak ada, tetapi peak current you boleh kira. V is equal to IR kan. So untuk peak current kita boleh kira lah, is equal to, peak current kita adalah V naught over R. V naught ada tak? Yes, V naught ada ni. V naught nilai ni ini dalam equation V yang ke atas ini. V is equal to 20 sin 100t. So 20 ini, kan ini adalah yang kat depan ni adalah V0. Sebab apa? So V is equal to, general equation dia V0 sin omega t. Jadi nilai depan ini, 20 itu adalah dia punya peak voltage. Okay, so boleh tak kita kira? Bolehlah. Kita masukkan dalam equation. So 20 bahagi resistor kita 10. Lepas tu set 2 lah kan. 20. Cuba kira. 20 and then bahagi dengan set 2. Okay. So ini adalah nilai lah. Nilai untuk boleh kira dulu IRMS. Okay, cuba kita kira. Kejap kita kira satu-satu. 20, so 2 lah. 20 bagi 10, so 2. Okay, so sini akan dapat 1.414 ampere. Okay, therefore, okay, so energy dissipated IRMS squared, it should be 1.414 squared times R is 10, darab dengan masa. Okay, masa dia tadi berapa? Okay, 3 minutes. So 3 minutes masanya adalah 3 minit tukar kepada 60 second lah. Okay. So, tekan kalkulator. So, dapat tak jawapan? Okay, cuba kira sama-sama. Okay, cuba kira sama-sama. Okay, darab 3 minit darab 60. Okay, so saya akan dapat 3,600 joule. Okay, so this is the answer. 3,600 joule. Okay, jadi dekat sini you kena faham lah. Okay, energy, this one, the amount of heat dissipated. Produce. Okay, sorry. The amount of heat produced. That's mean the energy dissipated in the resistor. So, this power should be power dissipated. So, you masukkanlah nilai ini. IRMS squared R. So, IRMS ni kena cari dulu. Daripada equation I0 over set 2. Okay. So, I0 tak ada. I0 peak current. Cari daripada equation V is equal to IR. So, I0 dia akan jadi V0 over R. So, V0 daripada general equation yang dia dah bagi itu, you tahu, oh 20 ini adalah 20 volt of the peak current. Okay. So, masukkan nilai, kita akan dapat IRMS dan kita boleh selesaikan. Okay. So, finish 5A. And then question 5B. Okay. So, look at here. We have capacitor. Okay. We have capacitor. Oh, sorry. So, we have capacitor connected in series with inductor, a coil, and then we have resistor. So, this is RLC circuit. Okay. And the source of alternating potential difference is given. Okay. So, kalau saya lukis circuit saya ada RLC circuit. Okay. So, this is 50 volt. Okay. So, RLC. Okay, so question number 1, the impedance of frequency. Okay, calculate the impedance of frequency. 50 kilohertz. So, frequency is given 50 kilohertz. So, we want to calculate the impedance. So, equation impedance pasti ramai yang dah hafal. R squared plus, tengoklah XC tolak XL ke, XL tolak XC, tengok siapa yang lagi besar. Tolakkan. Okay, tapi sebab dia ada squared, tak kisahlah sebenarnya, you akan dapat jawapan yang sama. Okay, so sekarang R kita dah ada. Okay, tapi XL dengan XC kita kena cari. Okay, so kita carilah dulu. Kita kira dulu. XC is equal to, formula dia dah diberi, gunakan sebaiknya. 2 pi FC. Okay, so you masukkan dalam equation. Okay, so it should be 1 over 2 pi F dia dah bagi tadi. 50 kilo and C, the capacitance. Okay, baca betul-betul capacitance tu adalah 3,200 pico. So, should be times 10 power of negative 12. Okay, so XC you akan dapatlah 994.72. Ini yang saya kira. Okay, you cuba kira. Alright, and XL, 2 pi FL, you masukkan nilainya 2 pi F50 times 10 power of 3 and L. L adalah 30 micro. Okay, so XL you akan dapat 9.42 ohm. Okay, 9.42 ohm. Boleh So, kita ada XC dengan XL. So, buat kat sebelah ni. Okay, sambunglah. Kiralah Z. So, Z you akan dapat square root R 5 ohm plus XC 994.72 minus XL 9.42 squared. Squared jangan tertinggal. So Z you akan dapat 985.31. Apa unit untuk impedance? Impedance adalah total opposition in that circuit. So unitnya mesti ohm. Kalau you tinggal tak ada unit, tak dapat jawapan akhir. Okay. And then question number 2, power factor of the circuit. Okay. So ramai juga yang dah hafal equation of power factor is cos phi. Cos phi is equal to R over Z. Okay. So, kalau you dah ada nilai R dengan Z, you can straightly use this equation. Okay, tak ada masalah. Okay, you nak cari power factor. Okay, tengok sini So, R, 5, Z kita dah kira tadi. Oh, senang je lah dapat jawapan. Okay, so this is the answer for power factor. And remember, power factor tak ada unit ya. So, jangan letak unit lah. So, this is the answer. Okay, tapi kalau you ada nilai voltage across R dan juga VRMS, kita juga boleh kira. Okay, contoh. Okay, kita ada VR. Okay, sekejap Contoh untuk soalan yang tadi ini, kita ada R, kita ada XC minus XL. XC lagi besar daripada XL. Nilai yang kita dah kira tadi. So, sebab itu arrow dia mesti ke bawah. Cacing. Kan? Cacing kat bawah. Okay, siapa yang saya dah ajar dalam kelas, so mesti ingat lah. Okay, so Z kat sini. So this is, okay, this is the phase angle. Okay, so dia akan jadi macam ni lah. Bila tadi you tulis cos phi, jadikan ini sebagai triangle. Ni. Okay, so dia akan jadi R over Z. Okay, tapi sekiranya you ada nilai VR, contohlah soalan lain, dia bagi you voltage across resistor. And then you ada pula nilai, this one should be VC minus VL. Okay, ingat So this is the phasor diagram in terms of impedance. Kita ada R, Z, XC minus XL. This is the phasor diagram in terms of voltage. Kita ada VR, VC over VL. And then the resultant here should be VRMS. Okay. So, angle kat tengah ini. So, kalau kita kata ada nilai VR dengan VRMS, can we calculate the power factor? Boleh. Tidak semestinya. Okay, tidak semestinya. Okay, you guna equation ini. Sekiranya you ada nilai VR dengan VRMS, you juga boleh guna equation ini untuk you cari apa? Untuk you cari power factor. Dan jawapannya sama. Ini dua ni. Okay, jawapannya sama. Tapi untuk jawab soalan ni tak perlulah saya nak guna equation ni. Okay, penatlah pula kita nak cari voltage across R and VRMS. Untuk cari power factor, panjang jalan kerjanya. Kita boleh straightly use this equation sebab kita dah ada nilai R dan Z. Boleh. Okay, so finish. So let's proceed to question number 6.